This is the continuity of the last presentation on current electricity. The same one on a NEET and EAMCET. Number of questions, weightage. Uh, this one. A copper wire of a area of cross section they have given 3.4 millimeter square. See, in this case they have given millimeter square, but while working out in a formulas we have to convert this one in meter only. So remember this idea. And the length of the wire they have given, this is 400 meter. Already they have given in meter, no need to convert this one. And a specific resistivity or specific resistance of the copper material they have given, that is 1.7 into 10 power minus 8 ohm. So this is about the resistivity. Then what they are asking in this case, the resistance of the wire. In the last presentation only we have seen about this one, the resistance of the wire. R here is, say, the resistance R is proportional to length of the wire and area of the cross section. So length of the wire is directly proportional and area of cross section here is inversely proportional. To take the proportionality, we have to include the constant that we call it as specific resistance or resistivity. For this one, R is equal to rho L by A. So this one, resistance of the wire, we have to calculate. For the resistance formula here is rho L divided by A. For this one, rho is about the resistivity. Already they have given the value, that is 1.7 into 10 power minus 8 ohm. Again, then length of the wire, already they have given that value here is 400, and divided by, and the area of cross section they have given, that is 3.4 into millimeter square. That we have to convert this one, millimeter means 10 power minus 3 into whole square, that is 10 power minus 6. So I just mentioned this one, 1.7 into 10 power minus 8, then 400, this one 400, and divided by 3.4 into 10 power minus 6. This one you can cancel over here. This one here is minus 2. Again, see, from this one 1.7, and this one here is 2 times. So from this one, 400 into 10 power minus 2 and divided by 2. Again, you just cancel this one. This is 200. 200 into 10 power minus 2. What you are getting, that answer here is 2 ohm. So for this one, answer here is 2 ohm. Next problem here is, two different wire have specific resistivity rho value and length L, area of cross section A are in the ratio. So resistivity rho 1 by rho 2 here is 3 by 4, L1 by L2 length here is 2 by 9, and area of cross section A1 by A2 here is 8 is to 27. Ratio of the resistance they have has here, R1 by R2. Already in the previous section we have seen R is proportional to L by A, so R is equal to rho L by A. Rho is called as proportionality constant, or even we mentioned this one as resistivity. From this one, from here, R1 I just mentioned here, R1 is equal to rho 1 L1 divided by A1. Similarly, R2 I just mentioned here, R2 is equal to rho 2 L2 divided by A2. In this questions, what they are asking here is R1 divided by R2. So from this one, I just mentioned here, R1 you just substitute the value rho 1 L1 divided by A1. Similarly, rho 2 L2 divided by A2. I just simplify this equation for the better understanding. Rho 1 divided by rho 2 into L1 divided by L2. Then by A1 and A2 are in denominator, this will come over here. From this one, for this I just mentioned here A2 divided by A1. Now, see, rho 1 by rho 2 already they have given that value here is, so they have mentioned here 3 is to 4. So I just mentioned here 3 divided by 4, and L1 and L2 the next value they have given 2 by 9, and third one is about the area of cross section they have given as 8 is to 27, but here we have to mention this one as 27 divided by 8. So this one what they have given here is A1 by A2, but what we are using here is A2 by A1, so I just reversed it. Now you just cancel it, this one, this is for 2 times, and This one again I just mentioned here. So what you are having here is 9 divided by 16. That one value here is r1 divided by r2. So answer here is 9 divided by 16. In this problem, we can use some shortcuts instead of working out the problem with some logic we can work out here. See this one, 4 wire made up of same material. Same material in this case, resistivity will be the same, but have a different length and radii. The wire having more resistance in the following. So what they are asking in this one, resistance should be more in this combination. That's what they are asked here. For this one, let me tell you here. See, for this, r is equal to, already we know this one, r is equal to rho l by a. And here rho value is constant because of the same material. From this one I just mentioned here, r is proportional to l divided by a. Even we can mention here, r is proportional to l divided by pi small r square. Now for this one, r is proportional to l by r square. See, the resistance should be maximum. That means length should be maximum because directly related. At the same time, radius should be minimum. So that what we are having here is resistance should be maximum. In this concept, what we are going to mention here is, see, they have given four different length, which is having more length, so that resistance will be more, which is having less radius, so that resistance will be more. See, there are four things is there. One is about length. Here they have given from this one, 10 centimeter, 50 centimeter, sorry, 100, 50, 100, 50. So this one, these two options will be there. See, because length is maximum, these two won't be there, so you just avoid these two. So this is not required. So next one, resistance from this one, which is having less radius, I'm sorry, which is having less radius. In this case, this one is having less radius, so that answer will be this one. The simple you can directly find out instead of working out the problem. The next problem here is a copper wire of a area of cross section they have given 0.01 millimeter square is used to prepare a resistance of 1 kilo ohm, that is about 1000 ohm. 1 kilo means 1000 ohm. The resistivity of the copper rho value they have given, rho here is 1.7 into 10 power minus 8 ohm meter. Calculate the length of the wire. What they are asking here is length of the wire, L value. So the same formula here. So I just mentioned here, R is equal to rho L divided by E. From this one, what we have to find out here is L value. So you just mention here, L you are going to keep in this side. So R A divided by rho. So again I just mentioned here, R value here is 1 kilo ohm, that is about 1000 ohm, into length area they have given, that is 0.01 millimeter square. So we have to convert this one, that is about 10 power minus 3 whole square. What you are going to have here is 10 power minus 6 divided by, and resistivity they have given 1.7 into 10 power minus 8. Now from this one you can cancel here, this is about minus 2 time. So 10 power minus 2, and this one I just mentioned here 1000 into 10 power minus 2. Again I just mentioned here, this is 10 power minus 2. Okay, divided by, see, 10 power minus 2 here is 1 divided by 100. That's all, simple one. Similarly here also 1.7, the pending value is there, 1.7 into 10 power minus 2 is there. So 10 power minus 2, 10 power minus 2 will be cancelled here. From this one, 1000 divided by 1.7 here. Simply you can simplify this one instead of cancelling time, working out the time. See, everything answer will be 58.82588 and for 0.58 and 5.8. That's what they have given. Simply you just round up this value 1.7. I just mentioned here 1000 divided by 2 for example, round of it. So what you are getting here is 500. So that answer will be, so what you are getting, the resistance, sorry, the length here is around 500 meter. So approximately 500 is the answer. So you just calculate. So answer here is 588.2 meter. Next question is, if a copper wire is stretched to make it 0.1 percentage longer, that is 0.1 percentage, you are going to increase. See here, see to that already they have given the hint 0.1 percentage longer in the sense you are once you are going to stretch you are going to increase. So in this case these two options, option number B and C, will not come. So only thing whether it can be A or B. See, before going to that, you just have an idea. Already they have given. So whether this is the answer or this one is the answer, we'll see. The percentage change its resistance is for this one first wire which is having a length is L and area of cross section A and material having a resistivity here is rho. So this one, this is copper wire, so rho will be the same. Only here is R is equal to rho L divided by A. This one, in this case, once you are stretching the wire, length increases at the same time area of cross section decreases. So volumes remains constant. Volume will not change. Volume I just mentioned as area into length. In this one, area here is area A is equal to, I just mentioned here, area A is equal to volume divided by length. Now you just substitute the value in this equation. So what you are having here is V will be there, L will go to the numerator, so rho L square divided by V. See, from this one, R is proportional to L square. This is equation number 1 I just mentioned here. Next one, from here, how you are getting from this one to this one. Say for this one I just mentioned here, for this case I just differentiate equation 1 with a simple equation 1. I just going to differentiate from this one, or if you are going to differentiate, what you are getting here is del R, that one will be equal to L. You are differentiate here, you are having 2L into del L. So this is equation number 2. What I am going to mention, equation 2 divided by equation 1 I just mentioned here, del R divided by R, that one will be equal to 2L del L divided by L square is there. So L will be cancelled here. From this one, del R by R is equal to, what you are having here is 2 into del L divided by L. Already they have given changing percentage change in the length, they have given the value, and this one percentage change in the resistance you are going to find out from this one, 2 into del L by L. Already they have given 0.1, so the percentage changes here is 0.2 percentage. This is the answer, the simple method, you just follow it. Next problem, a wire of resistance, they have given the value 18 ohm, is drawn until radius reduces half of its original value, which means once you are taking the wire, you are going to increase the length, at the same time you are going to reduce the radius. So area of cross section is reduces, length has been increases. The previous section we have seen the same. So volumes remains constant. Then the resistance of the new wire. See, once you are going to expand the length and you are going to reduce this one, compulsory resistance will increase. So one important clue from here is resistance will not be less than 18. You just remember this one. At the same time, they have given all the options which is greater than 18. Okay, now see, you just remember, have an idea of this. See, from this one, length of the wire you just mentioned, this one is L, and area of cross section here is A. A is nothing but pi r square, and this is a cylindrical wire, so what you are having, the area of cross section here is pi r square. Now this is about the formula for the resistance, R equal to rho L by A. Rho, this is about L. See, both the case, this is not 1, this is L. L divided by A here is pi r square. Next one, once the radius become half of its original value, so I just mentioned here R by 2. In this case, volume remains constant. See, for this one, in this case, volume here is area into length is volume. Area here is pi r square, length here is L. In this one, area here is pi r square, here radius is R by 2. This one I just mentioned here, R by 2, that whole square into L2. This one you just mention as L1. This is new length L2, or even you just mention as L1. See, from this relation, see, pi r square will be cancelled here. Only thing is L is equal to L2 divided by 4 will be there. So L2 divided by 4 will be equal to L, means L2 is equal to 4L. Next one, the new resistance here is R new is equal to rho L2 divided by A here. That will be equal to, see, what they have given here is rho into See, L here is already you know this one, L is equal to 4L and divided by pi R square. R here is R by 2. So pi R square divided by 2. 2 square will become 4. So 4 multiply over here. So 4 into 4, 16 into remaining thing will be equal to the formula here. R is equal to rho L by A. This one formula. You can refer this one from equation number 1. From here, what you are having here is 16R. Already they have given resistance here is 18. 18 into 16, what you are getting that answer here is 288 ohm. This is the answer for this question. Next one is, if and iron wire, see this one iron wire they have specified this one, so rho is remains constant, is drawn to decrease. See here they are not going to increase, here they are going to decrease its radius by 0.5 percentage. Then the percentage increase in resistance. See here, once you are going to reduce the radius, that means thickness of wire will decrease. Once the thickness is decreases, R is proportional to L by A. Hope you remember L by pi R square. Once the thickness is decreases, resistance will increase. Already they are mentioned here. Another one more thing is the percentage of increase in. So you have to find out increase in resistance. For this one, first one we just find out what is the decreasing percentage decreases in resistance. See here, del R by R, what they have given here is decrease, so that I just mentioned here minus 0.5 percentage. Percentage here is 1 divided by 100, so I just mentioned here 0.5 into 100. What you are getting here is del R by R here is, you just cancel it this one for 200 times, or even 5 divided by 100, you just mention a 5 divided by 10. So 1 by 2, 1 by 2 into 1 by 100, what you are getting here is 1 by 200. Next one, volume here is area into length. Area of the wire here is pi r square into length. This one previously how you have to find out, I just mentioned here, differentiate this one and divided by differentiated one to this equation, so that you will get this equation. Del v by v is equal to 2r into del r by r, plus this is multiplication log of AB equal to log of A plus log of B. Similar concept over here, similar in this case del L by L. From this one, there is no changing in the volume for this case. So already they have mentioned, only thing is you are going to reduce the radius. So you just mention here reducing radius, you just mention. See, and another one what they have mentioned here is increasing the resistance. We have to find out from here, once you are going to reduce your resistance length, not resistance, reducing the radius, your length will increases. This one we can find out with the help of changing the length with this equation. So del r by r, already we found the value, substitute the value, and del l by l. So from this one, this 200 will cancel. What you are getting here is 100 minus 1 by 100. In this case, what you are getting here is 1 by 100, that is about changing length. Then we are going to find out the resistance. R is equal to rho L by A. Rho L divided by A here is pi r square. Now again the same method what you are following here. Differentiate this one. Del R by R is equal to this one. Rho is same because this is ion. So this is the constant. Differentiation of constant will be 0 plus. And this one here is del L by L minus of, this is 1 by r square. If you are differentiating this one, minus 2r into del r by r. So from this one you just substitute here minus 2 del r by r, and del L by L you can substitute all the values here, and del R by R. From this one, del R by R equal to 2 by um, 2 by 100, you are what you are getting over here. From this one, just find out the answer, the changing the length, that is about the percentage increases. See this one, del R by R equal to 2, 2 divided by 100. So from this one, 100 percentage, you just mention this one, percentage increasing the length, we can find out from this one. What you are getting that answer here is 2 percentage. Next question here is, a conducting liquid is filled with a vessel of area of cross section they have given A up to height. See that the total similar like this. This is about the length of the wire. Similar here is the total. If you consider about the vessel similar like this, if the vessel is filled with the liquid, this is about the conducting liquid. The total length, say for example in this case, the total length. Or even a height of the liquid, we mentioned this one, this is about the length over here. See the total length and height both are similar in this case. Then the resistance of the liquid, already we know this one, R is equal to, this is the formula here. What we are going to find out, the formula here is R is equal to rho L divided by E. Here This is about the length, what they have given, the length, the total length, and even the height of the both conducting this one. This is about your uh, conducting liquid which is having the resistance. That one we are going to find out with the knowing the value of area of cross section of the cylinder, or even cylinder, and even density of the material we can find out here. For this one, simply you are going to replace over here. For this, see, the effective length here is L is equal to H. From this one, you just replace here. So what you are getting, that answer here is R is equal to rho H divided by A. Next problem here is a network of resistance is connected to 16 volt CS, 16 volt of battery with the internal resistance. Resistance, see here they have given separately internal resistance of this battery 1 ohm as shown in the figure. What they are asking here is the equivalent resistance of the network. See, equivalent resistance of the network in this case. What is the equivalent resistance in this case? This network, this one and this one and this one. See all these three, what is the equivalent resistance and voltage drop across AB and BC and CD. This one already I told, if it is connected in series, current will be the same. See here, they have mentioned in this case, I current will be the same, but the potentials are different. That's what they are asking, the potential difference. For this case, first one, see resistance between A and B, that is 4 ohm and 4 ohm, both are connected in parallel. This one how you can mention here is parallel connection. This one I just mentioned here in this case. This one here is, see I just mentioned here 1 by R equivalent, that one will be equal to 1 by 4 plus 1 by 4. This one what you are having here is 2 divided by 4, that is 1 by 2. So from here R equivalent will be equal to 2 ohm, that is for in this case of this one I just mentioned here. In this case, so equivalent resistance here is 2 ohm, and here is this is 1 ohm here, and this one similar in this case. This equivalent resistance I just mentioned here, 1 by R equivalent will be equal to, see I just mentioned this one, 1 divided by 12 and 1 divided by 6. What you are having here is 12, the common one I just mentioned here, 1 plus 2 here, this is 3 by 12. 3 by 12 here is 1 by 4. So R equivalent in this equation I just mentioned here 4 ohm. So for this case I just mentioned here, this is for this one, this is 4 ohm resistance. Now next one, this is 1 ohm. See for this one, all this 2 ohm and 1 ohm and 4 ohm all are connected in series. In this case you just mentioned here 2 ohm, 1 ohm, 4 ohm connected in series means R equivalent equal to R1 plus R2 plus R3. So this is resistance are connected in series. So the total equivalent resistance here is 7 ohm. So 7 is the answer for the equivalent resistance. Whether it may be A option or C option will be there. They have given 7 ohm resistance. Next one, what they are asking in this case, the potential voltage drop across E and B. Before going to that, this resistance we found out here, and another one more internal resistance of the battery, that is 1 ohm. If you found out this one, what you are getting here is total resistance of the whole circuit here is 8 ohm. See from this one, Ohm's law, using Ohm's law, V is equal to IR. From this one what you are mentioning here is, from this case, see I just mentioned here, I is equal to V divided by R. Voltage already they have given, voltage value here is 16, and what we found out, the total resistance here is 8. So what you are getting here is the total current crossing across the network, the total net current here is 2 ohms. See from this one, what you are getting, the current the across the all circuit network here is 2 ampere current is following across the network. See from this one, voltage drop across AB. So V is equal to, I just mentioned here, V is equal to I into R. For AB I just mentioned here, for current will be the same, and resistance for this case already we have mentioned, what we found out here is 2. The total potential here is 4 volt. So from this one, these two will be there. For this one, 4 volt we found out the value. For voltage across BC I just mentioned here, the same one, current will be the same, and resistance here is 1. So what you are having here is 2 volt, and voltage across CD I just mentioned here, I here is 2, and here is this value here is 4, what you are getting here is 8 volt. So that the total answer here is potential drop across A, B, B, C and C, D. They have given that answer. So that answer is this one. Okay, next important session is resistance in series and parallel circuit will be continued in the next question. And what are the topics has been covered, which has been given in the description in a word format. Even you can download that one. And any doubt, you just text a message to this in a comments, and anything you just ask in this one. Let me cover an important topic also. I just mentioned some of the shortcuts. Hope this will be helpful.